Okay, so we just took practice EOG for 8th grade science. I've gone through, crunched some numbers, and found the questions that were the most missed. And so we're going to look at those in this video, and this will be posted on Edmodo. So the first question shows up here. Whoops, that's not going to work. Okay. The graph shows possible changes to sea level over geologic time. Now, always read this portion up here. Anytime there's a graph or a diagram in a question, they always give you information about the graph. Next, you should always read the title and the labels so that you know what the graph is graphing. So we read the
1473, I need you to the NPR immediately for dismissal.
So when we read this, we see that it's changes in sea level. We have millions of years over here, and over here we have the sea level in meters. So we see that 542 million years ago, it was about 100 meters above sea level being 0. And let's see here, 200 million years ago, it was about like the current sea level. And then 0 years ago, that would be the present, and it's somewhere between 0 and 100. There's not a lot of detail to tell us. So now we read the question. What did scientists most likely study to construct this graph? Molten magma? I don't have anything to do with the ocean. Extrusive igneous rocks, sedimentary layers, foliated metamorphic rocks. Okay? So then, and sometimes what I do is I go back after I read the choices, I read the question again. What did scientists most likely study to construct this graph? All right, so when we look at this, we see the molten magma is eliminated because that would help you with volcanoes and stuff. And if it's molten, that's current. That's right now. That's not millions of years ago. Extrusive igneous rocks, no fossils. All right, so that's not going to tell us a whole lot. Foliated metamorphic rocks. Metamorphic rocks, if they do have fossils, they get distorted, and sometimes they get destroyed outright. So that's not going to really help us either. But sedimentary rock layers have fossils in them.
Elena Owens.
And since it has fossils, that tells us, are they marine fossils? Or are they land animal fossils? If they're clams, we know it was underwater. If they're saber-toothed tigers, we know it was dry land when that fossil was formed. So sedimentary rocks have fossils. They also have sediments. And again, sediments can tell us whether it was formed at the bottom of an ocean or whether it was formed at the surface. So the best answer here is going to be sedimentary rock layers. All right, so here we have the next question that a lot of people missed. How does upwelling generally affect the dissolving of gases in ocean water? All right, so there's lots of vocab here. And I've said over and over again, you've got to know the vocab. Upwelling, we need to know what that is. We need to know about dissolving gases in water, a liquid. So let's brainstorm. Let's write down everything we know. You're going to have scratch paper for the EOG. Use it, okay? Upwelling. As soon as you see the word upwelling, if you think, you should think cold, nutrient rich water. And that cold, nutrient-rich water is coming up from the bottom of the ocean to the surface. And when it gets to the surface, those nutrients act like fertilizer and cause the phytoplankton to reproduce like crazy. And since the algae and phytoplankton and stuff are reproducing, then you're going to get fish that eat the phytoplankton. And then you're going to get bigger fish that eat the little fish that eat the phytoplankton. So upwelling is a big deal for ocean food chain. Dissolving gases. So as soon as you see this, normally you want to raise the temperature of the solvent to dissolve more solute. But when you're talking about water or a liquid, it's different. So I'm actually going to go to a new page to answer this one. So dissolving.
Justin.
All right, so a couple little notes here. First of all, dissolving a liquid dissolving a gas in a liquid, higher solute temperature. So the hotter the water is, less dissolved gas. Okay? So what that means is in a lake or a pond or a fish tank or even the ocean, the hotter it gets, the less dissolved oxygen there is. The cooler it gets, the more oxygen can dissolve in it. That's why if you have a pond in your backyard, it's good to put it near some shade so that it doesn't get too hot during the summer. Now, we should make a special notation that the opposite is true for solids. If you want to dissolve sugar in water, you heat the water up and you dissolve more sugar than you do at room temperature water. That's how you make fudge. Okay? Now, going back to the question, right? Cooler water increases the amount of dissolved gas dissolved. Well, we said that we've got cold, nutrient-rich water. So it would be cooler water. And we just said that cooler water means more dissolved gas. But we got to read all the choices. Cooler water decreases the amount of dissolved gas. No, that's the opposite of what we said. Warmer water increases the amount of gas dissolved. No, that's the opposite of what we just said. Warmer water decreases the amount of gas dissolved. Now that's true. So A and D are both true statements. This is where they get you. We're talking about upwelling. The noun of the question is upwelling, and upwelling is cold water, so the answer has to be A. Okay? So don't let them trick you. They'll put true statements in there, but you've got to find the one that fits the question. Okay? So make sure you know what upwelling is. Make sure you know about dissolved gases. All right, going on to number 6, which most likely makes fish excellent indicators of watershed health. Okay? Again, I'm going to go to a new page for a second. A watershed, if this is North Carolina, all right, a watershed is an area where there's a river, and all the water, whether it's in a river or a rain, it all washes into that same river. That is a watershed. The water sheds off the land into this river. Concord is in the Catawba River water basin or watershed. So stick this in your brain. Watershed equals river basin. They're the same thing. They're the area where all the water runs into the same river. All right, so we're looking back at the question now. Which most likely makes fish excellent indicators of watershed health? All right, so there's some key words here. First of all, we're talking about fish. We're talking about indicators. More specifically, we're talking about bioindicators. Okay, we talked about these with our ecology unit. And watershed health. So why are fish a good bioindicator in watershed health? Well, if they live for a short period of time, that's not going to help us a whole lot because they're dead. Okay, they live for a month and they're dead. That doesn't tell us anything. What if we come to make water quality tests at a different time of the year? Okay, that's no good. Fish live in the water for at least a portion of their life. Fish live in water their whole life. Fish differ in their tolerance to the amount and types of pollution. Fish are frequently moving throughout different columns of water. Again, we have two true statements. Most fish stay in a particular part of a lake or ocean or whatever, but they do kind of move around. So they might go a little higher towards the surface. They might go a little deeper. And fish do tolerate different amounts of pollution. If you've ever had an aquarium, you know some fish are really hardy fish and some fish are not.
Kelsey Griswold, the front office for.
Okay, so all that stuff that builds up in the fish tank, that's natural pollution. They're whatever they excrete. So the best answer here is C. And this is what makes a bioindicator. A bioindicator is a species that is tolerant or not very tolerant of pollution. Usually, most bioindicators, they might be salamanders, okay, insect larvae, frogs, and of course some fish. These guys right here, they need healthy, clean water to live in. If it starts getting polluted, they are going to be the first to suffer and the first to go extinct in that water system. And so they tell us that the water is becoming polluted by their absence, right? This upwelling, that is a big deal for the EOG. Bioindicators is a big deal for the EOG. So make sure you know those. All right, so another question that a lot of people missed. Which of the following will reduce a home electric bill? So we are trying to reduce, that's key word, we're trying to reduce home electric bill. Now me, when I read this, I'm going to replace that with energy in my brain. We are trying to reduce the amount of energy using cloth napkins rather than paper towels. Well, that's good. That reduces waste, but it does not reduce electricity directly. Drying clothes on a clothesline on sunny days. Well, if you use a clothesline, okay, then you're not using a dryer. And dryers use a lot of electricity because it's electricity that makes them heat up. Keeping appliances plugged in when not in use. Okay, if the appliance is plugged in and that little red light on the front of your TV is on, that uses electricity. So that's not going to help you reduce. And again, reduce is the key word here. Using incandescent light bulbs in the lamps. Okay, so incandescent light bulbs, those are the stereotypical light bulb you see, right? And they've got the little wire that comes up and the little filament and the wire that goes back down. When electricity runs through this wire, it gets to this filament and it hits resistance. And because it hits resistance, that causes the filament to heat up. And as it gets hotter, it starts giving off light. Okay? So literally what you're doing is you're taking electricity and you're purposely slowing it down. And this kind of light bulb not only produces light, but it also produces a lot of heat. That's why they get hot. Incandescent light bulbs can get hot enough to give you really serious burns. So that is not correct. If it had said fluorescent or LED light bulbs, we'd give it a second thought. But incandescent light bulbs are not going to reduce your electric bill. Right? So the best answer here is drying clothes on the clothesline on sunny days, because that means you're not using the dryer. All right? Which best explains why the alkali metals are the most reactive group in the periodic table? So you're going to have a periodic table for the EOG, but you still need to know how to use it. So let's talk a little bit about the periodic table. The first group, the alkali metals, okay, this is group number 1. They are the most reactive. Okay. Group 18. Group 18 are the noble gases, and they are the least reactive. They basically do not react. Okay. Now, in general, everything over here except for hydrogen are metals, and there's a stair-step line here that indicate the metalloids. So everything on that line except for aluminum is a metalloid. And in general, the stuff over here, including hydrogen, is a non-metal. So we have the metals, the non-metals, and on the stair-step line, we have the metalloids. So again, which best explains why alkali metals, key word, are the most reactive on the periodic table? Well, we learned way back at the beginning of the year that reactivity is related to valence electrons. Okay, those go in the same bubble together. Generally, well, right, an atom wants to have 8 electrons in its outer shell. So if you're something like sodium, you have 2 in the first shell, and then you have 8 in the second shell. 1, 2, 3, 4, 5, 6, 7, 8. And then you have 1 more in the outermost shell. Now, sodium is a metal, and metals tend to lose electrons and become positive ions. Because what happens is sodium says, hey, if I lose this electron, if I lose this outermost electron, if I give it away, I now have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. All I have to do is get rid of this electron right here. And so that's what it does. It loses an electron, and it's really easy because it's got to lose 1. Right? Now we take something, a different metal, maybe a metal that has 2 electrons in the first shell, 8 electrons in the second shell, and maybe it has 3 electrons in the third shell. It is much more difficult to get rid of 3 electrons than it is 1. So this is less reactive. Whereas hydrogen here, or sodium, I'm sorry, this is sodium, is the most reactive, or one of the most reactive metals. Right? We take a non-metal over on the right side of the periodic table, maybe chlorine. Okay? Chlorine is going to have 2 electrons in the first shell. It has 8 in the second shell, and it has 7 in the third shell. Now, getting rid of 3 electrons would be hard. Getting rid of 7 is going to be near impossible. So what happens instead is chlorine gains an electron. And because it only needs to gain 1 electron, this is very reactive. Okay? On the other hand, if we take something like neon, neon has 2 electrons in the first shell, and it has 8 in the second shell. Wait a second. It wants to have 8 electrons, and it already has 8 valence electrons. So this is a noble gas. It is not reactive. Okay? So, to summarize, periodic table looks like this. Metals become less reactive as you go from left to right. These are the most reactive metals. Remember, hydrogen there is a nonmetal. Okay? On the other hand, the nonmetals become more reactive as you go from right to left. Because again, group 18 is the noble gases, and they do not react at all. Okay? So now going back to the question, why are alkali metals the most reactive? They're radioactive. No. They have complete outer energy levels. If they have complete outer energy levels, they're going to be a noble gas, and they're not very reactive at all. They have the highest atomic masses. That might affect radioactivity, but it doesn't really have anything to do with chemical reactivity. They have only 1 electron in the outer energy level. Ding, 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 ding. Okay? Because they only have 1 electron, they're not really doing much. Or, I mean, rather, they are very reactive. Okay. All right, a student sorted a list of disease and conditions into 2 groups. We've got group 1, tuberculosis, influenza, diphtheria, meningitis. Group 2, diabetes, arthritis, asthma, and cancer. Now, right off the bat, we should notice that group 2 are caused by health issues. Okay, so these are what we call non-infectious. And all of these are caused by bacteria or viruses or proteins. So these are infectious. Now we just noticed that right off. We haven't even read the question yet. The diseases and conditions in group 1 are. So that means we just need to think about this section right here. Are they inherited? You don't inherit influenza, which is the flu, by the way. Infectious diseases. Well, that sounds pretty good, but we read all the answer choices. Caused by environmental conditions. Not really. The environmental conditions, that's going to be your non-infectious. Not treatable with medications. There's treatment. There may not be a cure, but there's usually treatment for most diseases. So the best answer is B. These are infectious, and these are non-infectious. Okay? So make sure you know the difference for the test. Even if you didn't recognize meningitis or diphtheria or tuberculosis, you should have recognized influenza as the flu, and you certainly should have recognized that diabetes, arthritis, asthma, cancer, these are non-infectious. And if these are the non-infectious ones, then these have to be the infectious ones. That's why they give you this title up here that is a sorted list of diseases. Okay? Use the information they give you. All right, which has made the possibility of an epidemic, so that's a key word, becoming a pandemic much more likely in the 21st century. So first, we need to go back and we need to think a little bit, and we should think that epidemic is an outbreak in an area. And we should think that pandemic is an outbreak that crosses borders. Okay, so if Charlotte, North Carolina is full of zombies, that is an epidemic. When the zombies start crossing over into Tennessee, Kentucky, moving all the way up to New York, that is a pandemic. All right, increased deforestation. That might make travel a little easier, but not directly. Increased global travel. So you mean I could go to Brazil, get bitten by a mosquito, and catch the Zika virus, and then come back to North Carolina and spread it? Okay, that sounds pretty good. Increased vaccinations. That would decrease diseases, not increase their spread. Increased air pollution. That may cause some problems, especially for asthmatics, but that is a non-infectious disease. If we're talking about epidemics and pandemics, most likely it's going to be an infectious disease. So the best answer is B, increased global travel. Remember, epidemics is a local outbreak. Pandemic, it affects the large picture, a whole state, whole country, maybe even the whole world. All right, 23 here. Which is a benefit of genetically modified foods? Okay, so genetically modified, we're talking about biotechnology. Biotechnology. Okay, the cost of research is included in the cost to the consumer. The cost of food will decrease and the quality of the food will increase. When foods are genetically modified, they no longer need to be studied. When foods are genetically modified, they are completely resistant to disease and droughts. So we are looking for a benefit of genetically modified foods. Right? They are going to be studied for a very long time. They're being studied now. They'll probably be studied for the next 50 years. Right? When foods are genetically modified, they're completely resistant to disease and drought. No. Okay? No such thing as completely resistant to disease, because diseases can change too. Most diseases are caused by living things, and living things change. They evolve over time. Cost of food will decrease, and the quality of food will increase. That is a benefit. The cost of research is included in the cost to the consumer. That means you pay a higher price to pay for their research. That's not a benefit. Okay, so the best answer is B. Cheaper food that is better than the food we used to pay higher prices for. All right, so that is version A of the Practice EOG questions that were most missed. Hope you enjoyed it, or at least learned something. Have a good day.